Ever wondered how a robot arm in a video moves so smoothly? Or why a 3D animation of a door opening feels just right? It's not magic, it's science. Today, we're diving into a breakthrough called Part2GS, a method that's revolutionizing how we create digital twins of real-world objects. Let's break it down. Imagine building a 3D model of a door. Traditional approaches might make it look realistic, but when you open it, it might float through the wall or glitch out. Why? Because they ignore physics. They're like drawing a picture of a door without knowing how hinges work. That's the problem Part2GS solves. So what's the trick? Instead of treating an object as one big blob, Part2GS splits it into parts, like puzzle pieces. Each piece has its own rules for movement, powered by 3D Gaussian Splatting. Think of these Gaussians as tiny digital particles that form the object's shape. But here's the twist, they don't just sit still. They learn how each part moves, interacts, and avoids collisions. Here's where it gets cool. The system uses repel points, invisible magnets that push parts apart if they get too close. It's like giving each piece personal space to move freely. Plus, it adds physical constraints to mimic real-world rules. Joints can't bend the wrong way, and parts can't pass through each other. It's like teaching a robot arm to swing smoothly without knocking over a glass. The results? Part2GS is up to 10 times more accurate than old methods, especially for complex objects like robots or washing machines. It's not just about looking good, it's about acting right. Imagine training a robot to navigate a cluttered room, or creating a video game character that moves like a human. This tech could make all that possible. But here's the deeper magic. Part2GS doesn't just model objects, it teaches AI to reason about movement. Traditional models are like kids who can recognize a chair, but have no idea it's meant to sit on. They treat objects as static blocks, not dynamic systems. Part2GS changes that by giving AI a physics-powered blueprint of how objects function. Let's get technical. The system introduces 3 key innovations. 1. Contact loss, a virtual nudge that stops parts from overlapping. If a drawer tries to phase through a cabinet, the model feels that and corrects it. 2. Velocity consistency loss, ensures smooth motion. If one part of a robot arm jerks while another moves fluidly, the model flags that as weird, because real objects don't act that way. 3. Vector field alignment loss, acts like a GPS for each part, making sure every piece moves in harmony, like a well-choreographed dance. The results? Part2GS is a speed demon, especially for complex objects. In tests, it handled multi-jointed tools, appliances, and delicate structures with ease, something older models struggled with. Imagine a 3D simulation of a washing machine that doesn't just look real but moves like one. Doors sliding, drums spinning, all without manual coding. But here's the real kicker. This isn't just about better graphics. By understanding physics and part relationships, Part2GS could let robots handle objects more intuitively, improve virtual training environments, or even create digital twins of real-world systems. It's like giving AI a sixth sense for how things work. Of course, no tech is perfect. Part2GS needs paired movement data, like before and after snapshots, which isn't always easy to get. And symmetric parts, like 2 drawers moving the same way, still trip it up. But these are hurdles, not dead ends, and the team is already working on fixes. So what's the takeaway? Part2GS is a giant leap toward AI that doesn't just see the world, but understands it. And as this tech evolves, we're one step closer to machines that can interact with our world as intuitively as we do. If you want to see this in action, check out the visuals, because sometimes the best way to grasp physics is to watch it move. Thanks for watching, stay curious, and let's keep exploring the future of AI and 3D tech together.